So today we're going to look at systems where both of them are conics. I'm just going to kind of remind you, I'm going to pull the notes from last time so you can kind of see. If there are two conic sections, there's actually quite a few different ways that they could intersect. It's possible that we'll have no solutions, one solution, two solutions, three solutions, four solutions. So there's all kinds of possibilities for what will happen when there's two conic sections. I don't think I've ever seen that. Oh yeah, then that's the infinite, yeah. Okay, so looking at R2, can we tell what conic the first one is? Circle. Has two squared terms. Both the coefficients are the same. What about the second one? No. Hyperbola. One's positive, one's negative. So that would make a hyperbola. Ellipse has different coefficients, but they're both positive. Okay, so looking at these two, when we did conics with a linear function, we could use substitution because it was very easy to isolate a variable. We probably don't want to use substitution on these. We probably want to use elimination. Let's put a little note out here. On these, we want to use elimination.
Isn't that where you just subtract the two?
Yeah, you add or subtract the two to try and eliminate one whole entire variable. So when I'm looking through these, can I tell which variable will be isolated? Which variable would be canceled if I were to add or subtract? Yes. I'm literally even going to highlight those so I can kind of see that it's these two that would go away if I were to add these two functions together. If you want to, you can kind of try and rewrite it. I know some people don't need to rewrite it. Some of y'all can see it, but sometimes it's helpful to rewrite it and maybe leave a space and line these up better to where like the 39 is lined up with the -9. I'm going to rewrite it because I'm weird, but if you don't want to rewrite it, that's okay. So I'm going to keep the first one the same. Plus 39 equals 0. The second one, I'm going to make sure my x squared is lined up. My minus y squared is lined up. The second one doesn't have an x term, so I'm just going to write 0x. And then I'll put my -9 lined up with the 39. Okay, so now should we add or should we subtract? Add, yes, definitely add, because they have opposite signs for the y squared and the negative y squared. So if I add my first column, what am I going to get? 2x squared. Good. And then my second column is where they're going to, or my second, yeah, that's a column, will cancel. And then negative 16x plus 0x. Oh, negative 16x, I don't know where I wrote. Plus negative 16x. And then 39 plus negative 9 would be plus 30 equals 0. So basically what you have now is a quadratic equation. It's a quadratic that we need to solve. Mason had a good idea. What should we do? Divide by 2 and make those numbers smaller. Since it's equal to 0, you are allowed to do that. So that would give me x squared minus 8x plus 15 equals 0. Again, when it's a quadratic, you have different methods you can use to solve it. You can try and factor it. You can try and use quadratic formula, completing the square. Does this one look factorable?
Yep.
Yeah, it does. So I'm going to definitely try and factor it. We'd be looking for two numbers that multiply to 15, but they have to add to -8. Yeah, -3 and -5. So then we'll use zero product property, solve those little baby parentheses. So one would say x minus 3 equals 0. One would say x minus 5 equals 0, which means one x value is good and the other is good. Okay. So now that we have the x values, remember we had the same issue when we had this lesson on the Friday before the break. just because you have the x values doesn't mean you're done, because remember, you still have y values that pair with these x values, because the solution will be the point that they cross at. So you have to have an x and a y. So once we have our x, we still need to find the y's that go with those x's. So we're going to find y when x is 3, and also find y when x is 5. Now, unlike the lesson that we had on the Friday before spring break, we don't have a good place to plug this into. Both of these kind of look like they're going to be a little annoying to plug an x value into. Bottom one is probably better, yeah, but either would give you the same answer. All right, so for the first one, I'm plugging in 3 to the bottom equation, so that would give me 3 squared minus y squared minus 9 equals 0. Yep, because this would be a 9 and a minus 9. So negative y squared equals 0. Yeah, basically y is going to be 0, because you'll just have, if you divide by a negative, you still get 0. And then the square root of 0 is still 0. Okay, so that solution, I'm going to add it to the list. What point would that be? 3, 0. Okay. And then we have to find the y when the x is 5 now. So again, we can plug it into the same equation, that bottom one, which is a little bit easier to work with. So plugging in the 5 for the x will give me 5 squared minus y squared minus 9 equals 0. That would be 25 minus 9. So negative y, negative, not 16. 25 minus 9 would make 16 minus y squared equals 0. You could take this negative y squared and move it to the other side to get 16 equals y squared, which means y equals plus and minus 4. Yes. 4 or negative 4. Both of those. So this one x value gave us how many solutions? This one gave us 2, so we'll have 3 total. So this one we'll write 5, 4, and we'll write 5, negative 4. So there's all 3 of them. So this would be something like, you'll have 3 solutions. Obviously not, because this one was a hyperbola and a circle, but in some way, shape, or form, you'll get 3 solutions. Alright, let's look at the second one. Let's see if we can figure out what shapes these are. What's that first one shape? What conic is that? Hyperbola. Because there's 1 positive and 1 negative on the 2 squared terms. What about the second one? Hyperbola. Again, because there's 1 positive, 1 negative on those 2 squared terms. So let's see. Let's look through that. Let's see, are there any terms that we can maybe... I don't think anything will cancel right away, but you can multiply. Which one, Bailey? I don't even think you have to multiply the top by anything. Yeah, if you just do the... I'm actually going to do it by negative 2. The only reason I'm going to do negative 2 is just so they end up with opposite signs on those y's. So I can add, right. People are bad at subtracting. So the top one's going to stay the same. 3x squared minus 2y squared plus 5 equals 0. The bottom one, I'll have negative 4x squared positive 2y squared. And then minus 4 equals 0. So now I can see I have those y squareds that have opposite coefficients. These two right here. So those are going to be the ones that cancel if I were to add these together. So again, this process where we're adding them together is called elimination. Okay. So adding my first column, 3x squared plus negative 4x squared. Negative x squared. Okay. The second column cancels. The third column, positive 5 plus negative 4 is positive 1. And then 0 plus 0 is still 0. So this is just a tiny little baby quadratic that we need to solve. I can take this negative x squared and move it to the other side so that I get 1 equals positive x squared. Take the square root, which means x equals or negative 1. So 2 x values again. So that means we'll have a minimum of 2 solutions. We might have 2, we might have 3, we might have 4. So we'll still need to go back and find the y that pairs with each of these. Find y when, why is that in so far over? Yes? It shouldn't matter, whichever one is easier. The original, the one you multiplied, they should all give you the same y. Okay, I'm going to start with finding y when x is 1. Which equation do we want to substitute that 1 into? Yeah, the bottom one before we multiplied? Yes or no? Before, yeah. It doesn't matter. We should all get the same final answer. Alright, plugging it in for x. So we'll have 2 times 1 squared minus y squared plus 2 equals 0. 1 squared times 2 is 2. So negative y squared plus 4 equals 0. Which means y equals or negative 2, plus or minus 2. Yeah. So this one x value gave us 2 different y's. So if I'm writing out my solutions just for that one, I'm going to have 2 points. Both of them are going to have an x of 1. But one of them then has a y of 2, and the other one has a y of negative 2. That was just for the first one. That was just for plugging in 1. Okay, now plugging in negative 1, it's going to be the same thing, right? When you plug in negative 1, so we'll have 2 times negative 1 squared minus y squared plus 2 equals 0. So again, that turns into 2 minus y squared plus 2 equals 0, yada, yada, yada. Y is going to equal 2 or negative 2. So then that gives us 2 more solutions. On this one, the x value is negative 1. But then it'll be negative 1, 2, and negative 1, negative 2. So 4 solutions total on this one, which remember 4 was a possibility. And then one last one. Save the worst for last. Alright, what shapes we got? Not a parabola. Parabola only has 1 squared term. Hyperbola, yes, those are both hyperbolas. Okay, let's look through that. I can see the x's have opposite signs, but if I add these two together, would that make all of the x's cancel? No. Because the x's on the top are not going to cancel. Same thing, similar with the y's. I can see I have opposite y signs here, but if I added these two together, these y's, like the first y's will cancel, but not the second y's. And that's okay. We can still do it. Okay, so here's what we're going to try. I'm going to first just rewrite it so I can line up all the terms perfectly. So I have an x squared minus a y squared. I have a minus 12x. The top equation does not have a single y term, so I'm just going to write plus 0y plus 18 equals 0. Okay, and then rewriting my bottom equation, I'm going to bring its negative x squared term up front to line it up with the other one. Negative x squared plus y squared. And then we'll have, let's see, it doesn't have an x term, so I'm going to write plus 0x. But then it has a minus 4y plus 2. So if we were to add these right now, the only plus side is that you could actually get all the squared terms to cancel. Okay, so we're going to do that. I'm going to show you. We're actually not going to use elimination on this one. We're actually going to use substitution. We're just substituting differently than normal. So I'm going to add these as they are now. Adding them as they are now is going to cause my squared terms to cancel. But then I'll have negative 12x plus 0x, which is negative 12x. I'll have 0y plus negative 4y, which is negative 4y. 18 plus 2 is 20 equals 0. So this is a little linear function now. So what we're going to do with this little linear function now is we're going to isolate a variable on it so that we can use substitution. We'll be substituting this little linear function. I know, it's crazy. Isolate. Which variable y'all want to isolate? Y. Sounds great. Okay, so to isolate y, let me see. I'm going to move the y to the other side. So I'm going to plus 4y. Plus 4y. Which should give me negative 12x plus 20 equals 4y. And then one more step to isolate y. What would that last step be? Divide by 4. So we'll have y equals negative 3x plus 5. Okay, so we can take this little linear function and we can substitute it into either of the original equations. It doesn't matter which one. Substitute it into either of the original equations. Yeah, I actually think it'd be better to substitute in the first one. Do you know why? Because there's only one place you have to substitute it. You could do the second one. The second one just has 2 y's. It doesn't really matter though. Choose your own adventure. You should get the same final answer. Okay, substitute into, yes?
Would we be able to substitute it into the negative 12x minus 4y plus 20 in theory?
You would just get the same thing if you substitute it in here.
Oh, true.
Yeah, it's the same equation. Substitute into one of the originals. Again, Rishveda suggested the top one because it only has one y, so you only have to substitute in one place. You could do the second one, I promise you'll get the same answer. Alright, so we'll have x squared minus, and then in place of that y, we'll put negative 3x plus 5. Say it again. Oh, it froze? Oh, my bad. Thank you. For a second, I thought it just froze on the screen. Alright, so right here is where I put my y squared, and then we'll have minus 12x plus 18 equals 0. So now it's just one type of variable. Like if you look at it now, it's just all x's. There's no y's anymore. Let me see. I do need to FOIL this little guy out right here. That would give me, let me see, negative 3x times negative 3x would be 9x squared. And then that would be negative 15x and another negative 15x, which would be negative 30x plus 25 minus 12x plus 18 equals 0. And then what? Distribute that negative. X squared minus 9x squared plus 30x minus 25 minus 12x plus 18 equals 0. And then we can do a little bit of combining some like terms here. That would give me negative 8x squared. 30x minus 12x would make 18x. Negative 25 plus 18 would be plus 7. equals 0. I'm going to divide everything by a negative. Nothing else divides in all of them. I just don't like, if I have to factor or quadratic formula, I like my front number to be positive. So I'm just going to divide everything by -1. Yes, thank you. -7. Thanks, Gary. Alright, so that's going to give me 8x squared minus 18x plus 7 equals 0. Y'all think this factors? It does actually factor. It does. I know it doesn't look like it, though. Two numbers that it has to multiply to, what's 8 times 7? 56? It has to multiply to 56, but it has to add to -18. Anyone know those numbers? Yeah. It's definitely a 14 and a 4. They have to both be negative. Alright. To make Danny happy, I'll put the -4 closer to the 8x squared. And the -14x plus 7 equals 0. Group. GCF of the first group would be 4x. So that leaves me with 2x minus 1. GCF of the back group, -7. So that would leave me with 2x minus 1. Okay, so let me see. One factor is going to be 2x minus 1. The other will be 4x minus 7. So then to find our solutions, we'll take each one, set it equal to 0, and solve it using our zero product property. Solution to the first one? 1/2. Very good. Solution to the second one? 7/4. And guess what we get to do now? We found the x. What do we still need to find? The y. But we do have a great place to find the y. Where is a great place to find the y? Yes, right here. Y equals -3x plus 5. We can use that to help us find the y easier. You could also plug it into one of the original ones with all the squares and everything, but that seems like much harder to do. Alright. Find y. Why am I writing the word y? Find y. Say it again. What? Find y. Alright. Again, we can substitute them into this nice little place here. -3 times x plus 5. So for the first one, it would be -3 times 1/2 plus 5. That would be -3/2 plus 5. 5 would be, you could rewrite that as 10/2. Still has a value of 5, but now it has a common denominator. So I heard someone over here say it. What is it? 7/2. So if I'm writing these solutions, this solution would be 1/2, 7/2. Okay, and then yes? That's the same thing. And then for the second one, let me see, y equals -3 times the x, -7/4 plus 5. So that would be -21/4 plus 5. How do I rewrite that 5 as something over 4? 20/4. So -21/4 plus 20/4 is -1/4. So as a point, this one would be 7/4, -1/4. Gross, these did not turn out pretty like the other two. All right.